So good afternoon, everyone. Welcome to the first lecture of our school within the school on statistics using R. Yeah, these are a little bit different than using Python, but it's always good to see what else is out there and to what purposes you can use it. Yeah, and I know that according to the plan that we shared with all of you, Professor Freedom Gumetse was supposed to give the first lecture, but unfortunately, because of some last-minute problem, he can't make it today. But Christine Kraamwinkel, who was the lecturer for the rest lectures in the course, she kindly jumped in for this afternoon, and she will give the first introductory lesson in R this afternoon. Yeah. So Christine, it is your show. You're welcome to start. And maybe if you would like to spend 1 minute just to briefly introduce yourself. And, you know, it's always interesting for participants to know the background of whoever is teaching them something. And I will keep admitting the people that arrive.
Perfect. Thank you so much.
Thank you.
So I'm Christine Kraamwinkel. I've met some of you already, and you would have seen me in some of the other classes. I jumped in because I was curious about Python as well. I'm a lecturer at the University of Pretoria, and I've been lecturing first year students, and I've been teaching some of them are as well. And yeah, my research field is spatial statistics. We won't go into that. That gets a little bit complex. So we're not going to look at that specifically in R, but that's one of the reasons I actually started working in R, is because R has really good spatial capabilities. So I just basically jumped in. We were some of the first people at our university to start actually working full-time in R. If you know anything about University of Pretoria and stats department, you'll know that there was a lot of SAS happening, and we realized SAS can't do what we needed to, so we moved over to R for my research specifically. And now a lot of people are doing R in the department because it is so powerful. And it's actually very, very easy to use. So you might have noticed I've put a link here at the bottom of the screen. I want everyone to go jump in on that link. We're going to do some polls and things. I just want to ask you a few simple questions before we get started. So once you're on that website, you will see that it asks you for a session ID. So it's just ID 74. And then it will tell you once you're in, it will say poll closed. The moment I open a poll, you'll be able to see it on your screen. You can just log in on your cell phone and you'll see it there and you can participate. So my classes, I've always liked really, really interactive classes. So don't hesitate to put your hand up if you have a question. Type a question in the chat. I have the chats open on my other screen so I can see them as they're coming in. You can switch your mic on and speak to me. I'm friendly, as you probably noticed. And yeah, then we'll answer your questions as we go. So this session is going to end a little bit earlier than scheduled. We'll end by 3 o'clock. So if there's something that we want to leave over for Thursday, then we can do that as well. Or if there's anything you want me to go into more on Thursday, we can also do that. Okay, so I'm going to go to the first question. So I'm just put here, I want you to just tell me what your favorite hobby is. So I'm going to give you a little bit of time to do that. Just to get to know you guys and get you used to the polling software and get everyone in. So, coding. So I've set it up so that as you guys are typing and entering it, we will see what your answers are. And I'm wondering if any of you have done word clouds or seen word clouds before. So I see we have a dancer, we have a birder. So the whole idea behind a word cloud is the more people say a certain thing, the bigger that word will become in the cloud, and the things that are said very seldomly will be smaller. So at the moment, it seems like we're pretty even on this one. See, we have a timer, which I forgot to start the timer, but there we go. So we can see where we end up with this. And if you change your mind, you can always type something else as well, and it will replace your answer. So on the poll, you just type in what your hobbies are. I see Sisipo, I see you are hiking. Where do you hike? I also hike. I did an 8K with my dogs on a Sunday. Quite fun. So far, everyone's just has different hobbies, I see. So on the poll, you go onto this website, https://tcpoll.eu, and then it will ask you for an ID, and you just type that ID in, and that is the session ID that you will be using. And then 30 seconds left in this poll. So the next poll will also be on this. So it will close on your phone, and then you'll see the new question come up when I open it here. So I'm going to change my answer here just to show you what happens in a word cloud. And you can actually do word clouds in R as well. So you can see now cooking, I've just changed mine to cooking. So cooking has suddenly gotten a bit bigger. So we won't actually do word clouds in R, but I will show you how to figure out how to do it as well. Okay, so we know a little bit of what people enjoy here. So now I'm going to go to the more serious questions. So I want to know, once my computer responds again, how comfortable are you with statistics? So option A, again, on the same poll, it's going to open in a moment. You will just choose option A, B, or C. A is that you're extremely comfortable with stats, you feel quite advanced. B is you can get by, you know the basics, or you know nothing. So those are our options, just so that I know what level to pitch this class on. And the future ones. So I see we're mostly on basics at the moment. No problem with that. I don't know about you guys, but if anyone here studied statistics, whenever I say I do statistics for a living, I am met with wide eyes, and people are like, that's so difficult, but actually it's not a difficult thing at all. So once you understand the basics, you can go far with it, and it's really, really fun. Okay, so I see most of you are basic knowledge. Perfect. Okay, so let's see. Then my last question for now is, do you have any experience working in R&R Studio? So A, you're an expert, B, just a little bit, and C, no, you don't really know it at all. Joshua, everyone says stats is scary, but it's actually really fun. So once you get the hang of it and you understand the little tricks, it's super fun. My students always tell me I get very excited. I bounce around when I teach. So then they get excited. They don't know why. And before they know it, they're hooked. So the poll is on this website, ttpoll.eu. We'll do all of the poll questions on there. And the ID is ID 74. That's the session ID. Because there's many theories why people think it's so hard. So stats is tricky because you need to know so many different assumptions. You need to know why you do each test. And I think that's where the tricky part comes in. And it takes a bit of practice. There's still often that I find things where I'm not even 100% sure what the best approach would be, because life isn't textbook. So the textbook stats might seem really easy, and then you get to real life and there's missing data and things don't look right, and yeah, results don't make sense, and yeah, then you have to dig a little bit deeper. But it's like solving a puzzle, and I love puzzles, so that's probably why I enjoy it. Okay, so we're not going to go too deep into stats in this bit. I'm just going to do basic things, show you how you can do it, show you where the resources are that you can use to actually get dig a little bit deeper if you do need to. So yeah, so I see most of you are not top level R users. The good news, R is super easy to use. So we will look at a few examples just now. So I've just set up a few slides that I'm going to go through just to give you a basic idea, and then we'll go straight into R and we'll play around. So I did upload a script on on Moodle. I don't know if you've seen it yet, but that's what I'll be using today. So you're welcome to quickly go download it. You'll see some of the codes already in there, and some of it I'm going to ask you guys to do while we're busy. And then, yeah, that's pretty much how we'll do it. So this is going to be a very interactive type of session. So first thing I wanted to make you just aware of is that in R, we a lot of the time work with data frames. So this is very similar to what you did in Pandas. If you're thinking back to your other course, the Python course that you just did. So I think it's yeah, I'm saying the right thing. It is Pandas that I'm thinking about, where you also had data frames. So in your data frames, we'll look at a few of them just now, but you'll have your variables and then you have all your observations. So we won't go too much into that now, but the basic idea is when you look at a data frame, or whenever you do statistics, you want to visualize your data. That's always your first step, is to just understand what you're working with, to just look at the data, not to see all the answers, but to see, do I have missing data? Is there anything that looks funny? What am I dealing with here? So that's what we're going to start with. Once you've looked at your variables, you can also see how they're classified. So in statistics, how we deal with our variables will very much depend on what type of variable we're working with. So all variables can be classified as either numerical variables or categorical variables. So words or concepts that it could be numbers as well, but numbers that don't make sense for math. So for instance, if I say do a survey and you about your experience doing a course, 0 can be bad, 1 can be good. The 0 and the 1 don't really have numerical meaning. It's just something short, a label that I'm using. So in that case, it would be categorical data. Now, numerical data can be continuous or discrete, and in categorical data, we have nominal and ordinal. So most of you should have a basic idea of that, but ordinal means that there's some ranking system involved or some form of order in the data, where nominal is everything else. So it's basically you just have categories. So sometimes they call it regular categorical, some textbooks call it nominal. Now, once you know what type of data you have, then you can start thinking about visualizing it and analyzing it. So there's a website that I've put in the slides. I will add these slides on Moodle for you later. But there's some really useful websites, and I think this is specifically useful for people who maybe don't have too much experience with statistics, so that you can know what graphs are appropriate. So this website, Data2Viz, has these lists. You can say my data is numerical, or I'm dealing with categorical data, or there's some numerical and categorical data I want to analyze, maps, network data, time series data, and then it shows you what possible graphs can you do for each of these. So for instance, if you have one numerical variable, you maybe can do a histogram, or you can do a density plot. If you have two numerical variables and it's not ordered, you only have a few points, a box plot would make sense. Where many points, a violin plot might make sense. So this is all on that Data2Viz website. And if you go to the website, you will see that if you click on each of these buttons, it will take you to a page that tells you more about that type of graph, and it gives you example code as well, so that you can actually go play around with it and learn from that. So I actually still use it. I had to do some graphs the other day that I haven't done before, and I went here and I got an idea how to approach it based on this website. So then for categorical data, you can see there's a whole bunch of charts you can do there. They show you how to do Venn diagrams. If you have numerical and categorical, you can see there's even more plots that you can do. So I'm not going to go into detail with each of these. That's why I've given you the website. You can see what's appropriate for your own work. And then another really useful resource is the R Graph Gallery, where you can also go look at the different types of plots you can do, so that you get distribution plots, which is like your violin plot. We'll do a violin plot in this class later. I don't know if anyone's heard of a violin plot. You can let me know in the chat. You can do histograms, you can do density plots, box plots, and ridge lines. That one personally, I've never really used. So then it gives you correlation plots. And again, for each of these, if you click on that on the website, again, the website is given here, our graph gallery, then it will show you exactly how you can approach doing these plots. So just to see whether everyone is comfortable with variables, let's just look at a few examples. If we're looking at gender, obviously, this is what your data would look like. So if we look at this, we can very clearly see that this is categorical data. Now, if we look at the next column, sleep, any idea, anyone want to venture a guess what type of data sleep would be?
Yeah, I think it is a bit discrete.
Okay, you're saying it's discrete. Anyone think anything else?
Continuous.
Okay, so we have a discrete and a continuous here. Now, which one's right? Let's take a third vote.
Okay, now I realize it's continuous because we have 5.5 there.
Exactly. So
Yeah.
Discrete would be, it can only take on specific values, nothing in between. Continuous means it can be anything in the range. So this is definitely continuous. Now, if we look at the bedtime, what do you guys think this would be? Like the time someone goes to bed.
Interval.
Okay, we have interval here.
Categorical.
Okay, categorical. Let's see what the answer is. It is categorical and it's ordinal. So it's actually not a time, this is one of the tricky ones, is actually a label that we've given to a time of day. So it actually counts, if we do it in this way, it gives you an ordinal categorical variable, because it's just a label that we've given. You go to bed between 10 and 2 in the morning. It's not a number that you're going to do math with. Where if I'm saying the amount of sleep you get, the number of hours of sleep, that would be a numerical variable. So that's a tricky one. So countries, I think that one's straightforward. We all can see that's a discrete variable. And dread, I'm not sure what that was. I think that was a ranking variable. I can't remember what data set this came from, but I think it was how much someone was dreading going to bed or something like that. So it is categorical and it's ordinal, because the higher the number was, the more the person dreaded going to bed. But often when we analyze it, we'll treat it as if it's a numerical variable, although a number 3.5 doesn't make, it's not defined, but it makes intuitive sense. So those get a little tricky to analyze. So we won't go too deep into that. But the idea why I was looking at this was just to show you, before you can decide what graph to do or what analysis to do, you first need to think, what am I working with? What does it look like? What kind of response am I expecting if I ask this question or record this data? And then once we know that, we go to those tree diagrams and we pick whatever graph is most appropriate or analysis method is most appropriate. And then we can make our, we can carry on with our analysis. So I have one more. And that one is on the polling thing again. So again, if you go to this website, ttpoll.eu, and you go into the session with the ID 74, then I want to know, telephone area code, what type of variable is this? So I'm going to open the poll now, and I'm going to give you 45 seconds. And this one, I'm not going to show your responses until everyone is done. So we'll only see it at the end. So 12 more seconds. See, we still need quite a few responses, only have 11 so far. Okay, so we have 12 brave souls who answered this, and let's see what they said. So we are all over the place. So this is very typical when I ask this question. So the first thing we have to ask ourselves, is a telephone code something we would do math with? Yes or no? Anyone? Would we do math, sensible math with area code? Okay, so got quite a few no's. So that means it can't be A or B. So area code, even though it's a number, it doesn't actually make numerical sense. It's just a label that we have. Now, is there order to it? A logical order that always stays? No, there isn't. So this is actually nominal because yes, you can order them numerically, but does it mean anything if that order? It doesn't. So that's why it is seen as nominal. Okay, now hopefully everyone is awake. And these are the tricky things that you have to learn to deal with in statistics. Luckily, not everything is tricky, but I'm hoping everyone is wide awake right now. And we'll go into the simpler things now. Okay, so we're going to go over to R. And these are just a few things that you can do in R. It's not even a fraction of what can be done. We'll look at a few of them. So box plots, side-by-side box plots. There's numerical summaries as well. We'll actually start with that. Cross tabulations, bar plots with multiple variables, segmented bar plots, standardized segmented bar plots. I haven't put anything in today's notes about that, but these topics are all covered in a textbook that I recommended for everyone. And I will quickly go over to that. So in this document that I put on Moodle, you will see that I've explained how to install R in RStudio. So I want you guys to participate today with me, try and run some code while we're busy and try different things. You're not going to break anything, so you just try things. If it doesn't work, you delete the code and you try again. So there's a few different options. I don't know if you've installed R in RStudio yet. I would recommend that gets done. If you haven't done it yet, there is an online version that I'll show you now. It is a bit slower though. But I've explained here, first install R, then RStudio. If you first install RStudio, it's not going to run because it's like the shell without having a brain. So the brain is R, which you want first, and then you want RStudio. So I've added some video resources, also just YouTube videos that you can go and watch if you're unsure about how to do the installation. This Mac video also has some nice extra tips in it. So that's why I said that might be useful even if you're a Windows user. Now, if you have Anaconda installed, you would have already noticed, I remember Benjamin said last week that you can install RStudio through Anaconda as well. If it will take a while, most likely will take a while to install that way. And then it will ask you whether it needs to create an R environment. You just have to say yes, and then it will finish with the installation. So that's your second option if you want to go that route. Then the last option is to go through this link today. So I will show you Collab just now. And there you might have some functionality issues. Also, it is quite slow sometimes. So I'll show you one of the things just now in Collab, but you're welcome to use that. You can copy and paste your script from a text file into Collab. So that is an option. So then I've also asked that you install these. Don't stress too much if you haven't done this yet. This installation shouldn't take too long. You can also do it after class today. It's just your packages that we're using. We don't use it for everything though. And then some textbooks that I recommend. So this first textbook, the Introduction to Statistics with Randomization and Simulation, it's a free textbook. Both of these you can download. They're both by Open Intro. And once you've downloaded them, you keep them for free. So it's just important to follow these instructions. I know when I tried downloading the textbook, I didn't go register an account first. And I kept clicking saying, please send me the code, and it wouldn't send me the code. So you have to register first, then it will send it. But you just you'll see there's a slider and you just say you pay nothing for the book. If you want to pay, fantastic, but you don't have to pay for the book. And that is a really good resource. So in this textbook, they also have a lot of labs, which they show you different skills. So there's a worked example, and then they give you some exercises to try on your own. The textbook itself goes through a lot of R code, and most of the code in the textbook is available on their site as well. So these are very, very good extra resources. So I want to show you very quickly before we go into RStudio. I'm just going to show you Collab. So if you click on that link, it will open a window that looks something like this. You will see it has the extension IPYNB because Collab mostly works with Python as well. So you can use it as a Python interpreter, but if you use that link that I've given you to access it, it will take you straight into the R component. So where you can use the R call instead of the Python call. So what you would do is you would just type your code in here. You can add text as well. So you can add a text box where you can go type other things. That could be quite useful. If you then want to save it, you can save it to your drive, or you can copy all of the text in the end and save it into a text document. That could work as well. So I'm just going to remove this. Oh, no, it doesn't want to remove, so we'll just leave it. So if you want to do something in here, one of the first commands I'm going to show you in RStudio as well is just the data command, which shows you what data sets are available in R. And I want to show you here how long it takes versus in R. This subit was fast, probably because I ran it earlier. Sometimes earlier when I ran it, it took over a minute before it showed me a list of all the data sets available in R. So these are data sets that we could possibly use. And yeah, so if you want to work in this for now, you can just take that script file that I've given you, open it in Notepad, copy everything, paste it in here, and you just edit it here. Maybe just copy and paste line by line as we go, just because there is a space where I've made a mistake in the code, or I've deleted things because I want you to complete it. And if you haven't fixed it and you run the whole thing, it's going to give you some errors. So just be aware of that. But that's only right at the end. So if we're in R, just want to make this a little bit bigger. Hopefully everyone can see it properly. So if anyone can't see properly, just let me know. I'll zoom in a little bit more. But once you're in RStudio, this is basically what it looks like. So you have an area here very similar to Spider, where you can do your coding, where you save your scripts. You have a console. The positioning is a little bit different from what you have in Python, or in Spider at least, but you can run code directly in the console. So I often would work in my script, and then if I want to try something, I'm not quite sure how to approach a specific thing, I'll try different things in the console until I find the right code, and then I'll copy and paste it over into my script. Then you also have your global environment here, where you'll see all of your variables, you'll see your data set that's loaded, and then you'll also be able to see plots, etc. from in this window. So what I've done is I have done this script already for you guys. So if you want a new script, you would just click here and say new script. Or you can open a script, of course. What's really nice about RStudio is I've done it a few times where I accidentally close RStudio and I've forgotten to save my file. When it opens, it will be exactly what you had before. So you're not going to lose anything very easily. So commenting, as you've seen before in the other languages as well, there's different ways to comment. Here we're using a hash sign. So the moment I put a hash sign, everything after that is a comment, so it's not seen as code. So everything else that doesn't have a hash will be run as code. So I've already shown you this, the data bit. Now to run a specific line of code in R, we just click on the run button for that line, or you can just press Control Enter. So I'm not going to go click there every single time. I normally just press Control Enter. So I've run that code now, and you would have seen that it ran here in the console. So you can see exactly what you've run, and it opened the list of data sets for me here. Now, a little trick, which is shown in that Mac video, is if you want to just view that window now with the R data sets, just to see a little bit better what is available, you just press Control-Shift-1 on your keyboard. And that usually works, but for some reason today it does not want to work. Very odd. But yeah, normally that would make this a full screen thing. Don't know why it's not working. My computer does not like me very much. So anyway, these are all the data sets that are built into R. So you'll see here, this is in the package data set, which is always loaded. The moment you open R, it will be loaded, and you can go and work with this. So you can go look at any of these data sets by typing their name. So let's say, for instance, we want to look at this chick weight data set. Then I can go type in my console chick weight, and you would have seen it predicted it, and I just press the tab key to autocomplete, and I press enter, and you can see there's a whole bunch of data here, but this is not a very nice way to look at this data. So a nicer way would be to view it properly. So if I type view, and here I have to warn you that R is case sensitive. So if you type view with a lowercase v, it's not going to work. I often do that. So yeah, so I've typed view now with a capital V, chick weight, and if I press enter, then it will open the data set in a separate window. So this is a lot easier to then see what I'm dealing with, rather than printing it out in the console. So that is one difference also between Python and R. In Python, whenever you wanted to print something, you had to use the print statement. And Benjamin, if I'm talking nonsense here, feel free to let me know. But it looked like you always have to use that print statement, where here you can just type the variable name or the data set name, and it will print it out in the console for you immediately. So for homework, I'm going to ask you guys to go and have a look, just quickly glance through this, see what kind of data is there, just explore a few data sets and see what there is, if there's anything that sparks some interest for you. So this was just the preloaded ones. Now there's a lot of data sets here that we actually haven't looked at yet. So if we look at the open intro package, for instance, because it's not loaded currently, it didn't call up the open intro package. But I can, if I want to find out what data sets are available in that specific package, I can just go say, I want to know what data is in that specific package. So you would obviously have to know the name of the package. So open intro is the one that goes with that textbook that I spoke about earlier. So if we press here, Control Enter, this will now show us all of the data sets available in this open intro package. And I've actually used some of these data sets. I think we're going to look at this BioNTech adolescent data set in one of my examples. So lots of data to work with in R itself. Okay, so I see you say we don't have to use the print. Okay, good to know. Now I've learned something as well. Thank you, Benjamin. Okay, so this is if you want to work with data sets that are built into R, that you can use the data function just to see what data sets are available. You can also use your own data, and I went to the Python data.csv file just to show you guys as an example how to import it. So the first thing you would want to do is you would want to know what your working directory is. So working directory is basically where Python is working, or where R is working, or wherever, what program you're working in or language you're working in is going to look for its files. So in R, you can use the get working directory function to see what your current working directory is. And often you don't want to work in documents, so it's by default on mine documents. I want to work in the folder that I've created for this course. So I'm going to now go and set my working directory. I think my computer is, I think I know what the problem is, why my computer wasn't responding. It's my dog clicking on my pen. Okay, so I'll fix that later. Okay, so set working directory, you would go and just type in the path to the directory that you want to use. And if you go and check again, then you will see what working directory you are in if you run that code again. So you can see that my working directory has changed. So one thing to notice here, I'm not sure if it's the same on a Mac, but on a PC, whenever you set your working directory or a path, you have to do // not / in your path. So when you copy your path in your computer, in Explorer, and you paste it here, you just have to go and change all the slashes. If it's /, it's not going to work. So always /. I like setting my working directory so that I don't have to type the whole path every single time. Now to import your data, it's very easy, and it's very similar actually to Python. So there's a read _CSV function in Python. Here we're going to use read.csv. So in this case, I've specified the file I want you guys to import is Python data, Python data 2.csv. And we always want to put this in quotation marks when we're doing the import. Okay, I haven't actually tried the 2 / things. That's interesting. I will definitely try that later. Then I'll give you feedback on Thursday and let you know if it works on my computer as well. So this is how you would import a data set on your computer, which is in your working directory. So if I've done that, you can see it's just read it in. But that doesn't help me at all. It's not in my environment. It's not going to achieve anything. So I'm going to just say here, I want this to be assigned to my data. And I'm using, different from Python, we use kind of like an arrow. So it's the bracket and a line that you use to import or to assign something into a variable or into an object. So the difference, Python, I think it's a read _CSV. I only figured that out the other day. I've noticed when my first year students always give me read _CSV in their tests, and I've never understood why. Now I know it's actually because they're also learning Python, so they're getting confused between the two. Here it's just read.csv. Now if I've run this code, you'll see it has now created an object for me with 100 observations, 3 variables. And sorry, I just want to move this out of the way. Okay, so the data is now here, and you can actually, if you click here on this play button in front of my data, it will expand and it will show you more information about this data set. So you'll see that there's x.1 is your first variable, x and y are your different other variables. So this data set is what you used in one of the later assignments, I think in assignment 8 or something like that for Python. So just make sure you can read data in. So for the rest of this course, I want you guys to also think what data set you have. If you want to work on your own data rather than work on the data that's available in R or this Python data, feel free to work on anything you want to. If it's going to help you get some stuff done that you've been meaning to do, maybe you haven't done all your descriptors and things for your own work yet, then take this time to use to actually go and explore your own data. Now we have that data set read in. You can also read in built-in data sets. We'll get to that just now. Also, another thing to know about is just getting more help or information about data sets, functions. So for instance, if we look at these data sets here, let's say the AIMS data set, we can get more information about that by typing question mark and aims. And in this case, there's no information for that specific one. And the reason for that is because I haven't actually loaded the library yet. So if I want to load the Open Intro library, then I just say library, Open Intro. And you can see it's loading in the console. And if I run this now again, then I now get information here on the right-hand side about that data set. So here it tells me what data is in there, what format it is, what my variables are, what each of them mean. Sometimes you'll also get more information at the bottom about the source. That's quite often you'll find out exactly where that data came from. The same kind of thing works for functions. We'll look at, let's say we look at one that we've already used. We use the read.csv. If I press Control Enter here, it will give me in the help description for this. And we can go see what the syntax is. So this is really useful in R, that whatever you have a question about, you just press question mark and the name of the function or the data set, and you will get whatever information is available for it. Now we're going to move on to our first data set that I want to start exploring, which is the possum data set. So if I type here data and I put possum in there, then it will load it. You'll see that it's loaded it into my environment. We can also, for instance, go in the console and say, I want more information about the possum data set. And there we get information. So it tells me here, the possum data set is in the Open Intro library. It gives me a description where this data is from, what all the variables are, what they represent, and then what the source of this data is. And sometimes it gives you some example code that you can also run and see what happens if I run this code, what happens, let's say you want to get used to ggplot. You can go see what happens if you change head length and scroll width around, what will happen to your plot. What happens if you change the variable here associated with fill. So that's basically, that's a really useful resource to have. So now if we want to know more about this data set without actually going into the help file, you can also just get a quick list of the names by typing names. Half the time you can guess the code in R. It's very straightforward. So if I say names of possum, it's going to tell me these are all my variables that I have available in this data set. Now we can also view the first 6 lines of the data set using the head function. So again, head and possum, if I run that, it just shows me what the first 6 observations look like. So we have our variables. If you think back to that first slide I showed you, variables at the top. Now here, it's also showing me what type of variables they are. So the site is seen as an integer, then the population and the sex is shown as factors. Then again, we have an integer and then double. So that's kind of like your floats, if I'm not mistaken, in Python. It's a continuous variable. It's called a double in R. So that's basically it. So we can also get a summary of this data set. So if I say summary, then summary of possum, it will give me a summary of the entire data set. So you can see for each one, it will try to do a numerical summary. Obviously, population and sex, it saw as factors. So there it treated the summaries as factors. It didn't try to do any math on them, which is a relief because you can't do math on words. But for everything else, you can get a rough idea what's happening in your data set. So that's a very useful function. So let's say, for instance, you just wanted a summary specifically for the possum data, but you want it only for the ages of the possums. Then how we would access that is using a $sign. So you just say my data set is called possum, and I want to access something in possum. And then it gives you a drop down. You can click or you can type, doesn't matter. And If we run that, you'll see that we get the numerical summary of that one specific variable in the data set. So that's how we access specific variables. Any questions so far? I see it's quiet so far in the chat. Everyone's still with me. Cool. Awesome. Okay, so then we can also do frequency tables. So I've done a few examples already here for you. So frequency table, it's the table function. Like I said, you can guess half of the code in R. So there's a data set. The fast food one, you just want to see what that one is about. Fast food, again, in the open intro package. It has nutritional amounts for 515 fast food items. If we go and look at the names in fast food, let's just do that. Then you can see there's what information is basically available. So let's say, for instance, you want just a frequency distribution of the restaurant names. So you want to see what restaurant you're working or dealing with. Again, use the table function and you just say in fast food, go look at restaurant. And you can see they have Arby's, Burger King. So I think we can all tell that this is an American data set. If we want to do the same kind of thing for the BioNTech data, you'll notice here, I've just put the whole data set name in. So if I run that, I'm not telling it what variable to look at. In this case, this data set actually only has 2 variables. So if we just go to names and we use BioNTech, then there we go, group and outcome. So it automatically gives us this table. So if you go and do the same thing, maybe don't try this right now, but try it later on. Do table just for fast food and run that. You will see that it gives you an error because there's too many dimensions and it doesn't know. I think it ends up telling you there's over a gig of data and it can't process it. So yeah, you can make silly mistakes like that and then it will tell you, listen, whoa, there's something too big happening here. But if you have a small data set with just 2 variables, it will just do a cross tabulation for you automatically. Now, a quick exercise for you. I want you to just, and I think 5 minutes is way too much, create a cross tabulation of the restaurants and the trans fat content of the food. And whenever you've done it, maybe someone can just quickly share what code they used in the chat. So I want you to create a cross tabulation. So similar to this one, but for the restaurant data, that fast food data, and it should be using the restaurant names and the trans fat content of the food. So if you go back to the names in the data set, you'll see there's a trans fat variable there. So I want you to use restaurant and trans fat as your 2 variables in your cross tabulation. So I haven't shown you how to do it with 2 variables. So I want to see if you can figure it out. And remember, if you get stuck, there's always the question mark. So a 2-way contingency table, some people call it cross tabulation as well. There's many names for it. Let's write that here. Is there anyone who wants to venture a guess? I can also type and we can see together what happens with the functions. I'll give you a clue. It does start with table. And then we just need to add something in there. Okay, so first guess is fast food. And let's put then trans fat. So if I run that, then we only have the trans fats there. So we want a table with in the rows, for instance, the restaurant name, and in the columns, the trans fat content. Okay, should we do that? Let's try that and see what happens. So is that what you meant? Restaurant. I run that. We're running into some issues here. Any other guesses? So if we look at the syntax, I've put that up here. Might not help too much, but often there will be examples at the bottom. And I normally look for the simplest one. So you'll notice that in a lot of these, arguments are separated by commas. So shall we try something along those lines? Have a comma in there. Anything else anyone thinks I should add, or should I run this one?
Add a fast food.
Okay, let's add fast food. There we go. And there we go. We have it. So that's pretty much what would be needed here. So you could go through this help bit and go look for examples, or you can Google it. That often works. But yeah, that's the basis of a lot of bar plots then as well. So if we want to, for instance, do a bar plot of this data, we would often have to use the table function. So the bar plot function expects the data to already be tabulated. So you would use the table function, and you can do it with one variable in there or with two variables like this one. So that same bar plot, or that same function table that we did here can also be done in this way. Let me just copy that code. So I could have also created that table in this way, same as before, by just specifying which variables. This is just the good way to do it. If you know there's more than one variable or more than two variables, then you would obviously have to specify which ones you want to use. So bar plots, very easy to do, bar plot function. And we just press Control Enter, and there we have a bar plot. So this bar plot, you can then click on zoom to look at it properly. You can see some of the names are going a bit missing. We're not going to worry about that too much right now. I'll talk about that on Thursday. But if you want to go and save this, you can go and adjust this, the size of this plot yourself. Let's just do it like that. And then you can export it. If you're happy with this, I would not be happy with this plot. You can go and export it yourself. And you can see it's trying to save it now in the working directory that I've set up. So it will automatically go to your working directory. You can go choose what type of format to save it in. There's actually also other ways of saving it, images where you directly export it with, you don't even necessarily need to view it beforehand. And that works really well if you have a large amount of plots that you need to create. So you can create file names automatically, but if this is the beginner way of doing it, you can just go and export it here. So bar plots, we can do one of that BioNTech data as well. And you can see they had quite a very similar numbers of teenagers in both groups. And they had a vaccine group and a placebo group, and then they looked at who got COVID, who didn't. We can obviously add a legend. So to do that, again, very simple, just say here, comma, legend equal to true. And if we run that, you'll see it adds this. So this is the very basic. This you can almost think of as similar to matplotlib in Python, the very basic plotting. You can go a lot fancier with ggplot. Okay, so to load the possum data, you just say data and possum in quotation marks. Cool. So I think we are almost at 3 o'clock now. So what I would say, oh, what error do you get? Have you loaded Open Intro yet? So to load it, you would just say library. Sorry, my screen always does this weird thing. I think a cable's not properly connected. You first have to say library open intro, run that code, and then you can load the data. Then it shouldn't give you an error anymore. Okay. Let me know if it's working now. But yeah, so then the rest of this, I don't think we'll get through today. I've added a little bit about subsetting data, and you'll see I've added some exercises. You don't need to do it straight away. It's maybe a good idea to just have a look at it and try some things before the class on Thursday. There's some exercises that I've added, and then also a little bit about box plots and so also there's some examples that I've shown you. So maybe have a look at it, and then we'll go through that, and I'll add some extra things for Thursday's class that go into a little bit more detail. And I'll show you also how to export images without putting them through this window first. And yeah, then the rest of it, you can see if you get an idea for it, and you can bring any questions you have about this code. We'll finish up with this then on Thursday. And then we'll carry on a little bit more with the descriptives on Thursday. And then next week, we'll go over into the other topics. So I have here distributions, hypothesis testing, and maybe if we get time, a little bit of linear regression. So that will link up nicely with what you did in Python as well. But that is basically the plan then for next week. So yeah, that's everything from my side then for today.
Yeah, thank you very much, Christina. That was really a very nice introduction that I thoroughly enjoyed. And from the activity in the chat, it looks like everybody enjoyed it as well. I don't know if we have, if the participants have a few questions, because I know that today, as I mentioned before, Professor Gumetse couldn't make it. And Christina kindly jumped in, but she has another commitment just now. So maybe we have time for a couple of questions if there are urgent questions. Otherwise, we will meet Christina on Thursday again. Anyone? Yeah. If you have a question, you need to unmute yourself and ask.
Yeah. Yeah, I'm watching. Oh, I see. Isaac has a question.
Yeah, please, Isaac, just go.
Good afternoon, everyone.
Hi.
Yeah, my question is, you were explaining something on the ordinary and the nominal, and I wish you could throw light on that for me. It seems like I'm not getting that one clear. So if you can throw light on that for me, I'll be happy.
Okay. So nominal and ordinal, basically ordinal. If you have to classify something as either nominal or ordinal, always just ask yourself, is there some kind of clear order attached to it? So rating systems are very clearly ordered. So for instance, if you're asking someone about their enjoyment of a course or a restaurant, that rating system is there's a very clear order. So it's bad, average, good. So there's nothing subjective there. So if there's a clear order, something like small, medium, large, that's also there's clear order there. If there's no clear order or rating system, then it's nominal. Does that clear it up?
Yes, please.
Okay.
Thank you. I saw there were a few questions in the chat, but they got answered.
Okay, perfect. Perfect. Yeah, so yeah, and the open intro package, I actually only learned about it because that's the textbook is the one that we use at UP for the first year students, teaching them R. And we chose it because it's a free textbook and it has such amazing data sets in it, really, really good resources. There's videos, there's slides, there's everything on that website. And I must say the data sets are really good in there as well. So really good for playing around and getting to know R.
Excellent.
And for the illustration, Evander, can you maybe just explain what you mean by illustration? You mean the polling I did, or? The coding I did in RStudio. The poll that I ran was in using software called Turning Point. So that is paid software that the university provides me. So the one where I did the word cloud and the polls with you guys, that was using Turning Point. And then the other websites, I'll put those slides up later. It will be up by tomorrow with the websites with the different graphs that you can do for the different variable types. So those two websites, I'll put those slides up for you later.
Yeah, Christina, thank you very much. It was really a nice introduction to R, and I was really pleased to see that the Python specialists are also learning very quickly.
Definitely.
That's really very nice. Yeah. So Christina, you already advertise your next lecture. I think it's on Thursday afternoon, or if I remember.
Yes.
Yeah, perfect.
Yeah. Then, yes, it's.
We will see you again latest on Thursday afternoon. And I just do a quick reminder to the participants that tomorrow morning at 9, we have the second lecture on running atmospheric models. Yeah, so it will be also back to Python and running atmospheric models. So that will also be very, very interesting. Yeah, perfect. Then Benjamin invites everybody to join the appropriate Slack channel. Please do so if you haven't done so already. And yeah, and we will see you again in action tomorrow morning. Yeah. And Christina, thank you very much. And yeah, I'm looking forward to see you again on Thursday. Thank you.
Thank you. See you then. Bye-bye.
And a good afternoon to everybody. Thank you.
You too. Thanks.
Bye.
Bye.